Hi everyone. In this section, I'm going to speak about limit and derivative of vector functions. Let's start with the limit. Suppose r of t is a vector function which is equal f of t, g of t, and h of t. We say the limit of r of t when t approaches t sub 0 exists whenever the limit of f, g, and h when t approaches t sub 0 exists. And we have limit of r of t is equal the limit of these three components. For example, suppose r of t is equal square root of t 1 over t minus 4 and e to the t. We want to find the limit of r of t when t approaches 3. Let's check each component. As you know, square root of t is continuous at all real numbers that are strictly greater than 0. So the limit of square root of t when t approaches 3 exists and is equal square root of 3. The second component, as you know, 1 over t minus 4 is continuous at all real numbers except 4. So the limit of this function when t approaches 3 exists and is equal 1 over 3 minus 4, which is equal negative 1. And the third component, e to the t, is equal at all real numbers. So the limit of e to the t when t approaches 3 exists and is equal e to the 3. Therefore, the limit of r of t when t approaches 3 is equal square root of 3, negative 1, and e to the 3. The next part is about the continuity of vector functions. The continuity of vector functions is defined similar to the continuity of a real valued function. We say r of t is continuous at t sub 0 when three conditions are held. First, r of t sub 0 should be defined, or in other words, t sub 0 should be in the domain of R. The second condition is limit of R when t approaches t sub 0 should be exist. And the third one, the limit of R of t when t approaches t sub 0 should be equal R of t sub 0. At the previous example, as you see, since the intersection of these three subsets is all real numbers except all real numbers that are greater than 0 except 4, so the continuity points for this vector function is these real numbers. The next part is about the derivative of vector function. Suppose r of t is equal f of t, g of t, and h of t. We say the vector function r of t has a derivative at t whenever f, g, and h have derivative at t. And the derivative of r with respect to the t is equal derivative of f with respect to the t, derivative of g with respect to the t, and derivative of h with respect to the t. In the previous example, suppose r of t is equal square root of t 1 over t minus 4 and e to the t. If the derivative of r exists at t, we have derivative of r with respect to the t is equal. Derivative of square root of t is 1 over 2 times the square root of t. Derivative of this fraction is negative 1 over t minus 4 squared, and derivative of e to the t is itself. Here we have a new definition. Suppose C is a curve which is traced by r of t as a vector function. We say this curve is smooth whenever derivative of r with respect to the t is continuous and is never zero. So the derivative of r should be continuous and is never zero. That is, f of t, g of t, and h of t should have continuous first derivatives and are never zero together. What does it mean? When we say derivative of r with respect to the t exists, it means there is no any jump or cut on the curve. And when we say derivative is continuous, it means there is no any sharp point on the curve. And when we say it is never zero, it means there is no any maximum or minimum point on the curve. The next definition is about piecewise smooth curve. We say C is a piecewise smooth curve whenever it is made up of a finite number of smooth curves that are connected continuously to each other. Look at this curve. This curve can be divided to finite number of smooth curves, and these smooth curves are connected to each other continuously. So this curve can be piecewise smooth. Suppose this smooth curve is a particles path which is traced by r of t during the time interval I. At each time, like t, r of t is a position vector, and the end of this vector shows the particle's position, as you see here. Derivative of r with respect to the t is velocity vector. Velocity vector is a vector which is tangent to the curve at each time. And the direction of velocity vector is the direction of motion. The magnitude of velocity vector is called speed. The second derivative of r with respect to the t, if exists, or the first derivative of velocity vector with respect to the t is called acceleration vector. Look at the next example. The example says find the velocity vector, speed, and acceleration vector of a particle whose motion in space is given by the position vector r of t is equal to cosine of t I plus 2 sine of t j plus 5 cosine squared of t k. Okay, velocity vector is derivative of r with respect to the t. Derivative of 2 cosine of t is negative 2 sine of t I plus derivative of 2 sine of t is 2 cosine of t j. Derivative of cosine squared of t is negative 2 sine of t cosine of t plus times 5 is equal negative 10 cosine of t sine of t, which is equal negative 5 sine of 2 times t k. The magnitude of velocity vector is speed. So we have square root of negative 2 sine of t squared is 4 sine squared of t plus 2 cosine of t squared is 4 cosine squared of t plus negative 5 sine of 2 times t squared is equal 25 sine squared of 2 times t. By pulling 4 out, we have sine squared of t plus cosine squared of t, which is equal 1. So we have 4 plus 25 sine squared of 2 times t. And the last one, acceleration vector, is equal derivative of v with respect to the t. Derivative of negative 2 sine of t is negative 2 cosine of t I. Derivative of 2 cosine of t is negative 2 sine of t j. Derivative of negative 5 sine of 2 times t is negative 10 cosine of 2 times t k. We can find these three parameters in the time of, for example, when t is equal pi second. For example, v velocity vector at the pi second is equal -2 sine of pi second I plus 2 cosine of pi second j minus 5 sine of 2 times pi second k. Sine of pi second is equal 1, cosine of pi second is equal 0, sine of pi is 0. So it is equal -2I. Magnitude of velocity vector, which is speed, is equal, of course, at the pi second. We plug in pi second is equal 4 plus 25 sine of 2 times pi second. Sine of pi is equal 0, so we have a square root of 4, which is equal to. And the third one, acceleration vector at the point pi second. It is equal -2 cosine of pi second I -2 sine of pi second j minus 10 cosine of 2 pi second k. Cosine of pi second is 0, sine of pi second is 1, cosine of pi is -1. So it is equal -2j plus 10k. Okay, here is the end of this section. See you soon.